So then the next task. No, command. Up. So no, it is not the theoretical part. We just want to calculate some numbers. So what do we have? Number 6 and this is maybe a bit easier. So calculate median, arithmetic mean, unbiased variance, unbiased standard deviation, skewness, and kurtosis. What do we have to do? And we will in a minute do this also in Excel. Or at first, I think the median we can just directly calculate this. So what is the median of this distribution? So n is 100. We have 10 times 0, 20 times 1, 50 times 2, and 20 times 3. What is the median of this random sample? I think this we already have done last week. So the median is just the middle of our sample, roughly spoken. So you have to put your numbers in a row from the lowest to the highest. And then which number is in the middle. So we have 10 times zeros. Then we have 20 times a 1. And then we have 50 times a 2. And 20 times a 3. So we have an even number. So what we have to do is the 50th largest and the 51st largest number of our random sample, adding up, dividing by 2. So what we need is x 50 plus x 51 divided by 2. What is x50 and what is x51? x1 is 0, x10 is 0, x11 is 20, x30 is 20, x31 is 50, and until x81 we have also a 2. So obviously x50 is then 2 and x51 is also 2. So we obtain the median is just 2. I think this is not too hard to calculate. Maybe it's too early this morning. What is the arithmetic mean of this distribution? X bar is the sum over I from 1, in our case up to 100, over all xi's. And this will be so we have 10 times 0. 1 over 100. It's missing. 1 over 100 times 10 times 0 plus 20 times 1 plus 50 times 2 plus 20 times 3. So this is 1 over 100, 0 plus 20 plus 100 plus 60 is, hopefully I'm calculating right, 180 over 100 equals 1.8. Okay. So it's still saving my document. Therefore I have to wait. Unbiased variance. Unbiased variance was sigma hat squared 1 over 100 minus 1. I from 1 to 100 xi minus x bar squared. So then let's do this in Excel. How can we calculate this? Oops. This one. Here. 6. What do we have? We have 1 equals plus 1 up to 100. I think this should. Then we have 10 times a 0. We have 20 times a 1. We have 50 times a 2. So up to 80. And the last 20 numbers are a 3. So at first, let's use also the formulas that you practice to use Excel. So arithmetic mean means just up. There's something missing. Mean. So 1.8. Fortunately, we have calculated this in the right way. Then we need here xi minus x bar squared. So what we need is open brackets 0 minus x bar 1.8, and remember we have to fix this with $2 signs and we have to square this. Then we just move downwards this formula and we sum up this equals sum up of all these numbers and we have to divide this by our sample size 100 minus 1. So this is then 76 divided by 100 minus 1 and we obtain 0.77 roughly equals 0.76. So is saving? Still saving. Okay. Next one, unbiased standard deviation. What do we have to do? Well, just taking the square root. Oops. So sigma hat, of course, equals the square root of sigma hat squared. And this will be then closing brackets 0.76. Oh, 87 or 0.876. This 0.876. So, and then skewness and kurtosis. For this, we look up our definition of skewness and kurtosis. So we have this as the third moment of our distribution for skewness. And kurtosis was this one. So of course, calculating this by hand would take a bit long, but what do we need? Now we need just xi minus x bar to the power of 3 and xi minus x bar to the power of 4. So again, let's go to Excel, because there we almost have this. So 3, oops, and 4, and then we can take just this formula and put it in to this cell with a 3, and in this cell with a 4. We need, of course, all deviations going down to 100. And what else do we need? We have to sum up, dividing by our unbiased variance, and also dividing now by the number n and not n minus 1. Keep this also in mind. So we first again sum up all our numbers. And now for the skewness, we have to divide by standard deviation up to the power of 3 times the sample, the size of our sample, 100, and here to the power of 4 times the size of our sample. So this will be then this number divided by standard deviation to the power of 3 times our size of our sample, 100, closing brackets, minus 0.5 roughly, and in this case we just have to change the power in our formula, so interchange the 3 with the 4, and we obtain minus 0.57. So this will be then roughly minus 0.5, and this was 0. Oh, sorry. Here's something wrong. Of course, we have also to move to the cell not D, but E in this case. E, of course. So we have 2.62. So what is these numbers mean? Well, this number, of course, means that we have a slightly skewed distribution, and if we look at these numbers, of course, we see that here in the lower part, 10, 0 and 1, we have the numbers 10 and 20, and so the main mass of our sample is, of course, surrounded around the number of 2, and therefore we have a distribution which moves just a little bit to the right, and this also we see by the case that the median is 2 and the arithmetic mean is 1.8. And if the median, of course, is right in the position with respect to the arithmetic mean, then all our sample moves a bit to the right. And what does this number 2.62 means? Well, there we have learned last time that the kurtosis of 3 would be the kurtosis of the normal distribution. So we are, in this case, with respect to the value of kurtosis, we are quite near the normal distribution. So this would be then, I have to wait again. Now, oops, as you can see here, quite close to normal distribution, because the kurtosis of the normal distribution is just 3. Okay, then I think we stop here and we will do number 7 and 8. This we can do quite fast next week. And you know that on Monday we don't have any lecture because we have the workshop. Yeah. Then thank you very much for today.